All right, we'll get back at it here. So we're on problem 7. Problem 7, it says using the given coordinates, find the other coordinate that makes the ordered pair a solution of the equation. Okay, so part A, I have this equation. I know y is -3, so I need to find x. Okay, well, knowing that y is -3 means that x minus 5 times -3 equals 22. -5 times -3 is 15. So x plus 15 equals 22. When we subtract 15, x is 7. So the point, 7, -3, that would be 1 point on this graph. In part B, we have -3x minus 7y equals 2, and looks like x is 4. So if x is 4, we have -12 minus 7y equals 2. We add 12. -7y equals 14. Divided by -7, looks like y is -2. Okay, so the point for -2, that'd be 1 point on this graph here. Okay. So now everything that we've done so far has been kind of like review type stuff, you know. And we'll do that from time to time here in these notes in the class. But in problem 8, it says, is the table a function of x? If it is a function, write yes, and state the domain and the range. And if it is not a function, write no, and explain why not. Okay, so for a function to happen, each x value can only go to one y value. Okay, so I got 5 is going to 3, 2 is going to 7, -4 is going to -6, and 5 is going to -2. Now each x value can only go to one y value. So here, this is not going to be a function, right? Because I got 5 going to 3, and 5 is going to -2. Okay, so I'm going to say, no, it's not a function, since 5 does not go to exactly one y value. Okay, when it's not a function, we don't talk about the domain and the range. It wasn't a function to begin with. Okay, problem 9, is this table a function of x? All right, so let's see, the points 1, 3, 2, 6, 3, 9, and 4, 9 are in this set here. Well, 3 is going to 9, and also 4 is going to 9. So what? Each x value is only going to one y value. So I can have two different x's going to the same y value. That's okay, right? They're going to one y value though, right? So like 3 is going to 9. 3 is not going to any other spot. 4 is going to 9. 4 is not going to any other spot there. Okay, so yeah, this would be a function. Now the domain and the range are always sets of numbers. So it's important that when we identify the domain and the range that we use set bracket notation, or we use interval notation. I'll talk about that in the next page there. So as a set, the domain would be the set of all input values. So what's going into the function there, it's the set of all x values. That'd be the set containing 1, 2, 3, and 4. Okay. Now, if I'm using set notation, it does not matter the order of elements that I list, right? So like I could have said the set containing 4, 3, 2, 1, that's the same thing, right? So we don't care about the order, just that we got them all, okay? The range would be the set of all y values. So that'd be the set containing 3, 6, and 9. I got 9 written twice there. Do I need to write 9 twice in this set? No, I don't need to. I guess I could have if I wanted to. I could write the number 9 23 times if I wanted to. Why I would do that, I don't know, but I could. I would count that number that is 1 that is different from the others. Okay, so with that said, like there's no reason to write 9 again. Although I could if I wanted to. Okay. Problem 10, determine if y is a function of x. So for each x value, there's only going to be one y value. Okay, so I have part A, the equation y equals x squared plus 1. Well, each x value that I select is only going to produce one y value. So I'm not going to have two y values or three y values or something like that. You know, like if x is 1, 1 squared is 1, 1 plus 1 is 2, so 2 would be the y value. Or 1, 2, that'd be a point on this graph. Okay? So yes, that is a function of x. Now over here, I got y squared equals x plus 1. So I just said that for each x value, there's only one y value. There's not two y values. This is not going to be a function because if x is 0, y squared is equal to 1. So y could be 1 or y could be negative 1, right? Negative 1 squared is 1. So the points 0, 1 and 0, negative 1 are on the graph. Okay, now we're going to talk about the vertical line test shortly, but the vertical line test, that's a real handy test to use because, if I have a graph, I can know if the graph is a function. It's got to pass the vertical line test. So this one would fail the vertical line test. So 0, 1 and 0, negative 1 are on the graph. If I swing a vertical line across the graph, it can only hit one point everywhere, not 2 points. The next thing is a little bit with circles. So a circle in standard form is where you have the equation x minus h squared plus y minus k squared equals the radius squared. hk is the center point. Okay, so I want us to write the standard form of an equation of a circle with radius 2 and center point at the point negative 3, 1. Okay, so h is negative 3 and k is 1. So x minus h, x minus a negative 3, that's the same as x plus 3, squared, plus y minus k, y minus 1 squared, equals r squared, or the radius is 2, so 2 squared is 4. Okay, that would be the equation that I'd circle, okay? Now the next thing is I want us to graph the circle. Okay, so this circle has a center point at negative 3, 1. So if I go to the left 3 and then up 1, I plot that center point. And then usually how we draw circles is we'll start by plotting the center point there, and then we'll plot 4 points kind of hovering around the center, working off of the radius, and then we'll draw a circle as best we can. So here I've got a radius of 2. So if I go 2 units to the right of the center, that brings me to the point negative 1, 1. 2 units to the left of the center brings me to the point negative 5, 1. 2 units above the center brings me to the point negative 3, 3. And 2 units below the center brings me to the point negative 3, negative 1. So then after I have these 4 points kind of hovered around the center there, I'm going to draw a circle as best I can. Okay? Now, when you're drawing a graph, any graph, be neat with your drawing, right? Because like I'll have people just quick slop up something and they got a circle that kind of looks like this here, that's not a circle, right? So just I don't expect you to be artists, right? But take your time with the graph, okay? And you want to make sure that you have a graph that looks like a circle, okay? Here's another one with circles. Problem 12. It says to find the standard equation of the circle. Okay, so what if I had this graph? You know, what's the equation of this graph? That's the question. Okay, now the standard equation, the standard form of an equation of a circle, is where you have x minus h squared plus y minus k squared equals the radius squared. hk, that's the center point of the circle. So when I look at this graph, the center is at 2, -3. So h is 2, and y is -3. Okay? So I'm going to say x minus h, x minus 2 squared, plus y minus -3, that's the same as y plus 3 squared, equals the radius squared. Radius is 3. 3 squared is 9. Okay, and then yeah, circle that equation there. That'd be the answer. Okay. We'll go ahead and stop the video right here, and we'll pick up with problem 13 there in the next one.